unlike in traditional machine learning, once again, what we are doing, we are having lots and lots of historical data. We are training the model with lots and lots of historical data, and the machine is learning the patterns from lots and lots of historical data. That's what's happening generally. But in generative AI, what's happening is, yes, there is historical data. Yes, there is still uh, model training that is happening, and we'll see some of that as we go along. But in this case, we are ending up generating something completely new. It is not looking at a picture and trying to classify, is it an elephant, is it a tree, or is it a cat? But in generative AI, we are trying to generate a new picture of a tree, a new picture of a cat, a new picture of some kind of text. So we are trying to look at existing data, and we generate images which are similar to the ones that we train the machine on. And it doesn't necessarily have to be only images. It can be text, it can be videos, it can be audio, and it can be any other form of data as well. So we look at the historical data, we train the machine on the historical data, and on the basis of that, we try to generate content very similar to the original content. Now, when we talk about generative AI, there are effectively two very uh, broad categories that usually come up. One is large language models, which is going to be a big focus area generally for us. And the second is what we refer to as large multimodal models. So first we have large language models, and these are GenAI models that are pertaining to language data primarily. So they are trained using language models. And the primary objective of these large language models is to predict what is the next word in the sentence. So in a way, they are trying to, they are basically word prediction engines. I give you a sequence of words, I give you some text, I give you some sentence, and you're trying to predict what is the next word in the sentence. What is the next word in the sentence? And then you're using that to predict the next word in the sentence. So that is traditionally how large language models have always evolved. And even if you look at a GPT, a chat GPT today, how a chat GPT typically gives answers to questions, you ask it a question, you write a prompt, and you will typically see that the text is generated word by word. Not entirely word by word. It's actually so fast that you will not be able to see. Sometimes it's a word, sometimes it's an entire phrase, but you will still see there's a very sequential way how the content is generated. And that's a very important thing to keep in mind, that when these large language models are working, they are actually trying to look at the entire sequence of words or the entire sequence in the prompt or the question that you asked, and they're simply trying to predict the next word. Based on that, the next word. Based on that, the next word. That is what is going on behind the scenes. I'll show another demonstration of how this is happening in a bit more detail in a while. And the other kind of model, the other kind of category is large multimodal models, which are slowly starting to evolve in a big way today. Because if you look at all the general uh, models that are coming out today, they are mostly all multimodal models. This trend started especially from last year. So until last year, we only had large language models, and this is how the domain evolved. They were only working with text data. You give it an input text, and the model was giving an output, text. But what we have today, especially with all these newer trends like the Chat GPT, Ghibli style, Ghibli Studio pictures, and Google also has recently, you know, uh, released a very new image generation model. So what you can literally do is you can type a text, and they will generate an image, or vice versa. You input a picture, you can input a file, you can upload anything, and you can generate anything out of it. So that is what is going on behind the scenes when we talk about large multimodal models. Okay, so these are the two broad categories what we have generally seen. Although this is a very new area, it's mostly what you will see. A lot of what you will generally see is large language models in action. Okay, now, so what I have in this slide is to highlight some of the general application areas of LLMs. Now, there can be other broad categories we have, but I've generally seen that all the application areas can broadly be stacked into these five categories generally. Whatever use case you're working on, whatever application area you're working on, can be broadly stacked into these five categories. First is classification, question answering, summarization, code generation, and creative generation. So what is classification? Let's start with it one by one. And any business problem that you have, any use case that you have, uh, will generally be part of any one of these five categories. Any application, you can think of any general application, it will usually be a part of any one of these five categories. So first, let's start with classification. What is classification? Classification is where we look at a picture. Classification is where we look at a picture and we try to classify uh, what is the object in the picture. That's what we discussed in the Google Photos example. Now, aligning the conversation back to text, because now what we will do, we are discussing large language models. Major part of what we'll talk about, and mostly what we'll talk about from here onwards will be LLMs. So bringing our conversation back to text, what could be an example of classification for text data? So we look at some text and we try to predict what is the sentiment of the text. So I give you some review, let's say, and based on the text of the review, you try to predict what is the star of the review. Is it positive? Is it negative? Okay. So we look at the text of the review. So based on the review text, so we look at the text of the review. Based on the review text, we try to predict if the sentiment is positive or if the sentiment is negative. We try to predict the sentiment of the review based on its text. That is what we call classification. Another good example could be we look at some kind of technical documentation because the organization here works with a lot of technical documentations, right? So we can look at your technical documentation, or let's say there's some support ticket that is raised. Somebody has raised a support ticket. So we can look at the content or the text of the support ticket. And based on that, the model will classify what category that ticket belongs to. Okay. So is it what support category that particular ticket belongs to? So we can look at the text of the support ticket. We can look at the problem, and based on the text of the support ticket, the model can classify what category that particular support ticket belongs to. So these are all examples of classification problems. Based on some input, we are trying to predict some output from a known set of outputs. So let's say if we look at sentiment analysis. Now, sentiment can be either positive or negative. Users, you buy something on Amazon and you go to Amazon and you write a review, right? So your sentiment will be either positive or negative. Either you are feeling good about it or you're feeling bad about it. There can be nothing in between, right? Or maybe there's something or neutral, whatever. So it's only from a set of known categories that we are trying to do a prediction. So from a set of known categories, we are trying to make a prediction. Is the sentiment negative or is the sentiment positive? That's the way to look at it. So that is how we look at a classification problem. That's the way how we understand a classification problem, that the model tries to predict something out of a set of known categories. Then we have something called question answering. And classification, although I wouldn't call it a traditional generative AI use case, because classification problems is something, uh, and some of you who are coming from the world of traditional ML and DL, you can relate to it that we can already do classification using traditional approaches, right? And it is doable. We can very much do classification using traditional approaches. We can use traditional machine learning, count vectorizer, bag of words, right? Or we can use deep learning, RNNs, LSTMs to classify things. And these are all solved problems. It's not something that is new. We have been doing sentiment analysis for more than multiple decades now. It's not something that is new. But we have generally seen that with LLMs, these tasks are done in a more accurate way. They are done more efficiently and in a more accurate way. The accuracy of the tasks are generally more when we use large language models for these tasks. So when we see some of the demos on classification in our session, you will realize that the same sentiment analysis, the same product categorization, the same support ticket classification use cases can be solved using machine learning, and they can also be solved, using generative AI. So both the approaches can be used. Just that with Gen AI, we can get a higher accuracy and we can do it better. This is something that we have generally observed. Second category is question answering. Question answering is again something that is not new. We have done question answering. We had the technology for question answering uh, much, much before Gen AI. Today it's a big hype, I know, but even if you look at 2014, 2015, around that era, we had question answering systems even then. LSTMs were used, long short-term memory neural networks were used for question answering. You give it some question, you ask some question, and it was model was able to generate a sequence of responses. Okay, so this was not a new thing, but again, with generative AI, these kinds of things are done in a better way. Even with transformers, 2017 is when a transformer architecture was invented, and question answering was very popular that time. It's not something that is a new fashion today. These things were there that time as well. But just that with Gen AI, with the large language models, we are able to do it better. Okay, I will not talk too much about the architectures and all that because the focus is more on use cases for this part of the session. But because architecturally, once you take a deeper look at these LSTM models, these transformer models, you will realize that we have the technology for all this. But the large language models are able to do it better because we use pre-trained models for these tasks. Summarization is also something that is not new. We were able to do summarization before also. 2018, we had something called BERT, uh, transformer-based architectures, and summarization was done very well using those kinds of models. There were a lot of applications with summarization around that time. But again, with large language models, we are able to create summaries in a much better way. So you have it's almost a household application today. Anybody can be part of a Zoom meeting. You can do a Google Meet, and you can record the entire conversation. You can generate the transcript of the entire conversation, and at the end of it, the transcript can be summarized. The entire conversation can be summarized in let's say 100 words or 200 words. So summarization is a very common application today. Nowadays, you even have call summaries. Okay, even Truecaller has this feature. In Truecaller, you can record the entire call, the entire conversation, and your entire conversation will be converted to text. So let's say you have a big conversation you have with somebody. So you can record your entire conversation, and the whole conversation will be converted to text. And at the end of the call, Truecaller will generate a summary for you. It comes as part of Samsung. If you have a Galaxy device or maybe even Apple device, I'm not sure Apple how they do it, but in Galaxy, I have a Galaxy phone, and in Galaxy also you have this kind of a feature. They use Galaxy AI to do call assist and call recording. So you can record your entire call, it will be transcripted, and then you can, and at the end of the call the summary will be given to you. So once you have that entire text, you can summarize, and you can find out key action items and all those kinds of things. So summarization is also something that is not new. It is not a new use case, but we see a lot of applications, a lot of it's done in a better way today. Okay, and as we get deeper into the sessions, we will talk more about business specific use cases, but right now I'm just generally discussing. So there can be many practical examples of summarization from a business perspective. Some applications are obviously recording the meeting, recording the meetings, and creating a summary. It could be looking at a big technical documentation and creating a summary out of it. Okay, so let's say there are a lot of issue logs that you might be having. A lot of customers will come back to you with a lot of issues, and you will have a big documentation in terms of what kind of issues you're solving, right? And you don't need to go through that entire 1,000-page document. You can rather take a small summary. You can rather work on the basis of a small summary. That's the way how the summarization models can work. Summarization models can be very useful in the legal domain. That is another area where we see a lot of this is picking up in the legal domain, where typically the documents are very big, they're very long, the text is huge, right? And if you look at lawyers, they will have to sift through multiple documents. They will have to look at past case histories, and there's a lot of text data that we are usually working with in the legal domain. So summarization is a very good use case in those kinds of areas, I would say, where you can literally look at a past judgment, let's say, which is spanning 1,000 pages, which is very normal in legal domain to judgment, 1,000-page judgment, 10,000-page judgment is very normal. Okay, you can look at a entire judgment, and you can try to summarize that in a matter of, let's say, 100 to 200 words. Only look at the specific key phrases, and you can see how helpful this kind of a thing could be for lawyers and judges, to take decisions. It is not to say that AI will replace everybody, but it is to say that AI will make people more efficient. AI will make the processes more efficient. Okay, it will make the judiciary more efficient to focus on things that are actually important. Okay, so next time when you're in a courtroom, and if you've ever seen a live courtroom proceeding, and all the courtrooms, many of the courtroom proceedings are recorded nowadays, right? So you can actually see that the lawyers and judges, they waste so much time. Like uh, you can actually Google out today Supreme Court. You can see some live courtroom recordings. You'll see how much time is wasted by people are going through documents, people are reading article number this, article number that. So there's so much of time that gets wasted through all these references. So AI can actually help in a big way. If there are ways we can summarize it, if we can build a question answering system, so AI can scan through those 10,000 pages. You don't have to manually look up, but the AI system can go and retrieve the answer to your questions based on uh, what you're asking at that point in time. Okay, so that these are some of the good applications we can look at. Yeah, technical support documentations are also very, very good. So okay, so let's say you're working on some product, okay, and you ship your product to some customer, and typically the technical documentations will be very, very big. But what you can do with summarization, you can summarize it to only a few pages, so that the customer has the most up-to-date information in a very summarized manner. Okay, the same also applies for lot of contracts we sign on a day-to-day basis. This again borders on the legal domain. But next time you open up a bank account, there is always a terms and conditions sheet, right? It is that dreaded TNC, the terms and conditions section. You want to take an offer, or you want to open a bank account, you want to take a credit card. For credit cards and all, there is an MITC, most important terms and conditions and all that, right? So it's very hard. It's very big, no? I mean, if you see that booklet is usually like 20, 30 pages, it's huge. Now, nobody has the time to go through all that. So these are again very classic use cases, which even something like a chat GPT today is able to do very well. So today you can literally download that MITC, upload it on chat GPT, and ask it to summarize it. These are some very, very good applications of summarization that, from a day-to-day perspective, everybody can start using. And of course, from a business perspective also, okay? Or maybe even question answering. We can extend the use case to question answering. What you can also do is you can go and upload that terms and condition sheet, and you can start asking questions. You can say that, hey, when was the last time this happened? Okay, let's say you buy health insurance. There's so many clauses. There's so many potential clauses in a health insurance, like how much of co-payment, how much of there's a lot of hidden things that are there, which are usually part of the terms and conditions section. Okay, and it's very important because when we get hospitalized and when we want a claim, we want things to be processed seamlessly. That time we don't want issues to happen, right? So it's very important to like understand every single aspect of the terms and conditions part. Okay, so you can potentially think of a question answering system where normal users can upload their health insurance documents, and they can ask a simple question and they can get an answer back. Now these are some very, very revolutionary applications that were not there before. Yes, we had general question answering systems. The kind of thing I'm talking about today is much more accurate with LLMs and with the powerful language models that we have today. It's a lot more accurate. They're able to give you the answers in a much more accurate way. And it's an evolving system. It's an evolving system. It's just the more data you get, the more training you do, the better it gets. There's always errors that they will make, but they will get better at it. Okay, so there are lots of applications you can think about it. Next time you think of look at any business case, or you look at any day-to-day thing that you're working on, you can relate to any of these five categories. You usually not find something beyond this, but between these five categories, you can usually fit it generally. Okay, classification also from a business perspective. I talked about sentiment analysis and product categorization, and we'll see more as we get into some of the general discussions. Okay, and the last two categories are something which is very, very new. I would say the first three, we still had ways of doing it before. Historically, we still had methods for achieving it. But the last two categories are something that have really picked up over the last few years, I would say, especially with generative AI. So code generation and creative generation. So code generation is one area where I would say a lot of interest is taking place right now. So there are a lot of companies which are very, very big in this space in terms of code generation. So there are a lot of tools, and there are a lot of different types of uh, applications we have where you can which can assist you in generating code. The companies like Cursor, there are companies like and there are extensions that you have like GitHub Copilot. Okay, even Google Gemini has an extension on VS Code. So VS Code has lots of extensions. There are standalone applications that are available which can assist you in writing code. And I'm not talking about code completion. Standard code completion has been a part of code editors for a long time. Even 10 years back, you had basic code completion, syntax-based code completion, right? So you say PRI, and the model will automatically complete print, because print is a very standard keyword in many languages, right? So when you start typing PRI and you hit tab, it just knows it is print. But when I talk about code generation is something very different. Code generation means you can literally hit a comment, and you can say what you want to do, and the model will generate the entire code for you. That is what code generation is all about. If you want to see a couple of applications, we can see that. Again, I mean, this is a very, very different topic, so please don't worry. I just wanted to highlight to you how code generation actually happens. And you can see I opened up a, a code file. This is actually a Python script. It's a Jupyter notebook file. So the code is Python, but it's actually a notebook format, a Jupyter notebook kind of a format that we are using here. That's what we are doing. And what I wanted to demonstrate is, and this is using a platform called Google Colab. This is the same platform that we will be using in our class as well. So each one of us, we will also be able to take advantage of this feature. And Colab has something called Gemini built in. You can actually launch Gemini on the right hand side. These are very, very new things that have come up, especially in the last 1 year. None of this was there, before. And this is a particularly one area where we see a huge amount of growth has happened. One of the good things of GenAI has been this. It has made developers more efficient. Yes, a lot of downsizing has happened with respect to a lot of redundant jobs probably, but maybe it has made developers more more efficient in a way, right? So and the best part is it is very context sensitive, right? So if I just try to run the code here for a minute, so I'll connect to my GPU and show you a couple of instances of this. This is within the platform. You also have extensions within VS Code where you can effectively write some query, get some answers. And I'm sure some of you know this, but just for a few of the folks who have not seen this kind of thing. So so this is a neural network I'm trying to build. So technically we are trying to build a neural network. So I've got multiple dense layers, and what I can do is I can just add a comment. Okay, so let it download here for a minute. I can simply go and add a comment and see how Colab will automatically write the code for me. So when I give a comment, Colab will automatically write the code for me. Colab will automatically say that okay, this is what you might want to do, and it is very very context sensitive. It will not give me a general answer. It is not going and copy pasting something on Chat GPT. Chat GPT will give me a generic answer. Okay, but one of the good things about the code generation tools today is that they're giving us context sensitive answers. Like for example, if I start typing here, so what I will do, I will just start typing model.add. Okay, very interesting. I'll just start typing. Look at this. Can you see? I just start typing model. Can you see what has happened here? So whenever I just type model, MODEL, it has given the rest of the part in gray, and it understands based on where my cursor is right now. The editor understands that this is the most likely piece of code I might want to write. And this is powerful. I didn't do anything. I didn't type anything in English, nothing I did. I simply started typing normally. And Colab understood that this is the most likely piece of code you might want to do based on what thousands of developers have done. And I can just hit a tab and it's complete, right? Completed. I can hit enter and Colab will recommend further. Can you see 60? I can hit tab, complete, and it recommends further. It keeps recommending it, right? So as you can see, it's very interesting. Not only this, what I can also do is I can also go and comment out. Okay, I can just go and comment out something. I mean, again, it's technically a different topic, but I can say add dropouts. I can just say add dropout. This is a comment. This is we can use hashtag to give a comment in Python. I can just comment out and write something in English. And when I say add dropout, see what it will do. It will actually go and add a dropout layer in Keras. Okay, so it's giving it in gray, but I can just go to tab and it adds a dropout. Okay, so I can just go and take that, copy paste that code. So after every dense layer, I can add a dropout. Let's say as an example. And then what I can do is I can go and kind of hit enter. Okay, and do you see this? This is magical, no? I don't know if you find it magical, but I mean it looks magical because I actually see this pattern. All of you, dense, leaky relu, batch noun, dropout. You don't have to understand what this is. This is deep learning stuff. Okay, some of you who know deep learning will relate to it. But this is the architecture of Keras actually we are building. Okay, so this is the dropout layer which I added right now using commenting, and the model understands that this is the pattern. And next time I do enter, it understands I should add dropout here. See, it understands I should add dropout here. See how cool this is, right? And it understands I should add dropout here. It's not a random thing. This is not a random thing. So just because I added dropout in the first place, the machine understands that dropout is the best thing to do. The dropout is basically a way to regularize the network. So we try to reduce, like when I say point to dropout, we try to reduce 20% of neurons randomly in the network. That is what happens. So this is one of the fascinating things about code editors today, that they are very context sensitive. And this is a capability we did not have before. Okay, so this is not like going to GPT and writing some code, getting an answer. This is very context sensitive based on how you're coding, what you're coding. it will be able to give you the answers. Right. Anyways, this is my saved notebook. I'm just going to edit it back to excuse me, where it was. And this is not just with respect to this. There are a lot of other uh, platforms. And if I have to give you some examples of some of the biggest platforms that are available today, there are some examples like Cursor. Cursor is a very popular company today. It is a very popular company, and they are a separate application. So Cursor is a separate application that you have, and you can see some of the things that Cursor does. Cursor is even used by companies like OpenAI. Even OpenAI is using something like Cursor to for their to the developers are using this for code development and all that. And you can see it knows your code base. You have something called code chat. Okay, so you have something called code chat, and Cursor is huge, by the way. We are talking about a $9 billion company. Can you imagine? This is just a software, and this is already valued at $9 billion today. Okay, huge. And it's a standalone application. You can't. It's not an extension, unlike VS Code where people use extensions. This is a standalone application. And on the right hand side, you can go and you can type, you can write something in English, and Cursor will generate the code for you. You can say accept, and it will integrate. It's very similar to Copilot. I'm not saying it's something very different from GitHub Copilot or things that are already there, but these are some better applications. They're able to do it better in a way. And this is again a lot to do with the kind of models that they're using. So to be a little bit more technical, Cursor uses the Cloud Sonnet model by Anthropic. If you know Anthropic, just like the world knows OpenAI, GPT, that's what everybody's talking about. But if you look at coding applications and all these code generation tools, one of the most popular language models that works very well for code generation is Anthropic's Cloud model, Cloud Sonnet. The latest version of it is what Cursor uses. And many of the other code editors, if you see, there is some of the competitors of Cursor that are there. So there's something called Windsurf and all. So Windsurf is also a very popular company. So code generation is again a very big area where we have seen a tremendous amount of improvements happening. And finally, creative generation. Creative generation is where we use generative AI to generate pictures, images, audio, and all those fun applications that you see. Right? It's not new, but with today's technology and with today's language models, we are able to do it better. Right? So you can use GenAI to write an article. You can use GenAI to create a new story. You can edit an article, all those kinds of creative generation process, or write an email. Is a part of day-to-day life today. You can use GenAI to write an email. And these are again part of the creative generation things that we have today. So these are the 5 areas that I wanted to list out. And as I said, any problem statement that you're working on, anything that you're generally seeing or working on, will usually fit into these 5 areas. Okay, either it will be a classification task or a question answering task or a summarization task or a generation task or some kind of a creative generation kind of a task. Okay, wanted to show you one more example. This is again related to question answering that we did. There's apparently something called Perplexity, which is a kind of like a search engine, a competitor to Google, right? That's what Perplexity says. They're a competitor to Google, and this is also incredible. This is also using generative AI and trying to use generative AI for their search. So Google also has this feature. They're very recently starting to roll it out. Next time you search anything on Google, I mean, historically that's how Google has been for the last decade or so, right? You search something on Google, and what happens is you actually get a a link, a series of links, the most relevant links that point to your search. But what Perplexity is doing is they're not only giving you the link, but they're actually answering the question. Okay, so I hope this gives everybody an idea in terms of the capabilities and what we have and what large language models can do.